Welcome to the final exam, question number 16, and this is what we are given. We're given a W24 by 68 beam, which is going to be here. And that's W24 by 68. And then this is the W27 by 102. All right. And then it also lets us know that we have two 4 by 3.5 by 3/8 inch angles, and then we have 6 3/4 inch diameter A325 which are slip critical, and there's 6 of them. And that should tell you right off the block that slip critical is typically going to control. So this should control in the slip critical, and it's asking, what is it asking? What is the capacity of the connection? It says you may use the tables on page 128 and 130. And that's the quickest way to go about it. Just use these tables and figure out what you need. Some other thoughts that you want to have is at what point, where is going to control on this is what I'm trying to say. And let's assume that this is going to have a smaller web. First of all, you have to check the bolts and shear. I mean, if you have this load coming down right here, are those bolts going to be able to handle that? And what we have is, if you look at it where the web meets these two double angles, or not two double angles, just the double angles, then you have a double shear. So right here, it's a double shear. Let's write DS, hopefully, and D double shear situation. And then on each side, so you're going to have this angle, and then you're going to have an angle on the opposite side of this web right here. And then those are both going to be single shear situation. So these are in single shear. But there's 2 in single shear. So there's 6 in double shear, and there's 12 in single shear. I hope that makes sense. And let's go ahead and figure out what the web thickness of each of these beams are before we go any further. And to do that, you can go to if you have a steel book, or I think they're going to give you shapes of beams, just reproduced or something like that. So go to the front of your steel book, and that's where all the properties are. And sorry, my piece of paper falling off the table here. All right, so we got a double W24 by 68, and W24 beams, or W beams, are at the first of all of them, so they're pretty easy to find. W24 by 68, and I am there, and it looks like my web thickness is 7/16. Let's use that, 7/16, and that was W4. So this has a TW, thickness of web, of 7/16 inch, and that's what we'll use. And then we've got the W27 by 107. So flip back one page because they go up. The further left you get, 120. No, it's 27 by 107. 107. Is that right? Because I don't have a 27 by 107 in my book here. 27 by 102. That's better. 27 by 102. I do have one of those. And the thickness of the web is 1/2 inch. So TW equals 1/2 inch. And right now that should tell you, hey, this will control, and therefore we're going to have to deal with this. But because this is smaller, has a smaller thickness, and I hope that makes sense, because this is bearing on, this is much, this is going to be about half as much bearing, because this is bearing on 1, 2, 3, 4, 5, 6. So if you look in there's a hole in this web, a hole in the 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 web, and a hole in the web, and those bolts are bearing on it 6 times. Now if you look at this web, it's going to be bearing on it 12 times, because there's 1, 2, 3, 4, 5, 6, and then on the other double angle on the opposite side of this web right here, there's another double angle. So you're actually going to have 12 times 1/2 inch as opposed to 6 times 7/16 inch. So I hope that makes sense to you. But this will control right here, the W24/68. And typically when you have this double angle, it's always going to control. And I feel comfortable saying always because I'm not going to see a situation, I don't see a situation where it's not going to control, because, you know, often than not, you're going to be bringing the smaller beam into the girder, and therefore the girder, and you're going to frame it in like that. All right, that's enough. I'm just going to go ahead and solve it, and hopefully I haven't bored you to death already. Okay, we have, so there's two ways that this can fail. Right now, we know it's slip critical. So we know that either this can fail, the slip critical part of the bolts can fail, or the bearing can fail. Bearing of those, if it does slip, you have to check, you're supposed to check the bearing on the web. Bearing on web. And that's the bearing of these bolts on the web if it fails. So I'm going to tell you right now, this is probably going to control. And when you have slip critical connections, 90% of the time, it will control, if not more. All right, so we go to use those graphs, and they said to go to pages what? 128 and 130. In your steel book, it should be around 4, 5, looks like. Yeah, 4-5. And 4-6 is the bearing and the shear. So what we'll do is we'll go to, I'll just use the one in the study guide, 128. All right, there we are. And we have A325 bolts, slip critical. So you want to go down to bolts, A325. You want to go to SC class on the top there. And we have STD holes, which is standard round holes, I'm assuming. And you go to the right, and we have double shear at this point. So let's go 17 double shear and go over. And you can see that we have, what is our diameter of holes? 3/4, and I see 15 kips. And I'm going to multiply that times the number of bolts, which is 6, and 15 I think is 90. I'm going to use my calculator. I do not trust my head math at all times. 99 correct. Alright, I should have put this right off here. So this corresponds with that. So that's our slip critical. So its capacity is 90. So if this has a higher capacity, that means this will control. So whichever has the lower capacity will control. And then the bearing on web, let's put it down here. And you can go to the next, I think it was the next page, what was it, 130? Which is also the next page in your steelbook. Let's just flip over, and you see that it is table 1-E, I think, or it might be I-E. 1-, let's say 1-E. And our material thickness, we said, was 7/16. So go down to 7/16. We have a FU of 58, because that's what A325 is. And look around in your steel manual to find and justify that. It has a list of types of steel and what their FY is and FU is the ultimate tensile strength. Alright, so 7/16 inch. We have FU, we have 3/4 inch bolts, that's 22.8. And that is what? That is allowable load in kips, which it says on top there. And you want to multiply it. That's per bolt, so you want to multiply that by 6. Yes, because we have 6 bearing on there. So 22.8 times 6. And you can already see that it's going to be more. 136.8 kips. And another way you can do this bearing on the web, and this might be faster for you, but you could say, I believe that the bearing equals, I think it's spec. I'll also go to the spec because I don't want to mess this up, but I think it's 1.2 let me write down what I think. I can just erase 1.2 FU times the bearing area, if that makes any sense. So it's going to be the diameter of the, actually it's going to be times number of bolts times pretty much a bearing area. Let's say that. So, but the specification, I think it is chapter J, I know that. So go to specs, chapter J, and J3, and I think it's J3.7. Yes. And they say FP, that's what they call it. FP equals bearing area, or bearing, and then allowable bearing stress. That's right, bearing stress. Alright, and it says equals 1.2 FU. Oh shoot, FP equals 1.2 FU. And I hope that makes sense, because this is going to be, what, 1.2 times 58 KSI equals 1.2 times 58, 69.6 KSI. And then you have to get kips, you have to multiply this times the bearing area, which, as I said before, is going to be 3/4 inch times 7/16 inch. So 7/16 times 0.75. So this equals, I better write it out, 7/16 inch times 3/4 inch equals 0.328, let's say. And then the number of bolts is 6. So let's go ahead and figure that out. We had 1.2 times FU, which is 58, times the number of bolts, which is 6, times, I'm just going to go ahead and do 7/16 times, actually, no I won't. I'll just use that rounded off number, 0.328. And I get 136.97, which 136.97 is close to 136.8. So if you don't remember where to get this, which is probably easier to get this, or if you just simply want to check, you have the time and you want to check it, you can go to your specification section, and you'll see F the allowable stress and bearing equals 1.2 FU. And I hope that makes sense. You can just check yourself. All right, I will see you on question number 17.